Hello friends, welcome back to our channel on statistics. So we are in engineering mathematics playlist. Okay, so in the last lecture 2 we have discussed about row reduced echelon forms, right? So if you have any doubts in that you can comment or you can contact us. So lecture 3 is about rank of a matrix. Okay. So it's very simple concept and very powerful topic also I can say in the machine learning or the deep learning whatever it is. So first I will discuss some formal definitions and with applications, then we will move to some examples. So first, so formal definition. So number of linearly independent rows or columns present in the matrix is nothing but the number of linearly independent rows or columns presence in the matrix. So what it says, so for finding the rank you can use row operations or column operations. You can apply any operations. Okay. So what definition says now? So for example, there are you are having 10 items. Okay. So from the 10 items, for example, item 1 to item 10 you are having. Let's say item 3 is dependent on item 2. Okay. In that case, what you can do, either you can eliminate item 3 or item 2. So it will reduce the data dimension. That's what rank concept says. Smiley for data reduction means data reduction to reduce the data dimension. So if you want some more applications, let's say you are having, so come to the applications. Let's say we're having 10 web pages, web page 1 and web page 3 and web page, like that you are having 10 web pages. Okay. And you can just take examples for our create whole website. So in engineering mathematics there are 10 lectures. Let's say if you see the lecture 1, lecture 2, lecture 3, so I want to calculate dimension for this. Lecture 3 already includes lecture 2 concepts. So why? Because in lecture 3 it is row reduced echelon form and lecture 2 is row echelon form. So row reduced echelon form contains row echelon form. So in that case I can eliminate lecture 2 to reduce the space or storage whatever it is. In that case I can use the rank concept to find the similarity or whether similarity presence or not there in the context. If it is present, just eliminate it. That's it. So if you go to the numerical examples, for example, let's say I'm having 1 to 2 4. So it's my matrix data 2 cross 2 matrix. So if you can see that R1 is 1 2 and R2 is nothing but 2 times multiple of R1. 2 times multiple of R1. So what is, so when I will apply that row operations here, you will get 1 to 0 0. So what is the rank here? How many non-zero rows are present here? 1. So 1 is the rank here. Very simple concept. And if you take 3 cross 3 example, let's say we are having example like, for example, we are having 1 to 0 3. So it's upper triangular matrix. If you can see here, rank will be the 2. Why? Because 1 2 will be the one direction and 0 3 will be the another direction. There is no dependency presence there. Let's see one more example. Let's say we're having a matrix 1 5 4. Okay. Then 0 3 2 and 0 3 2 and 2 13 10. So this is your given matrix. Now we need to find the rank of a matrix. So for finding rank of a matrix, there are so many shortcuts are there, so many simple ways also there. First I will go with general procedure, then we will discuss shortcuts. Okay. So if you want to go with general procedure, is nothing but you need to convert into identity matrix. There you will get to know that how many zero rows are present or zero columns are present in your matrix. So already in second row starting element is 0. Now my aim is to make this one is 0. So how can I make this one 0? So R3 implies R3 minus 2 times R1. So 154 and 032 0. So when it will be 5, 2 times means 10. 13 minus 10 is 3, and again here 8 will be there. 10 minus 8 is 8. Now you can see clearly here row 1 is dependent, row 2 is dependent on row 3, or row 3 is dependent on row 3. Why? Because this one is similar. So now what will be the rank? Rank will be the 2. And again you can see here, if I want to make row 2 as a 0, if I make this term as a 0 by using row 1, let's say, okay, and again here uh, some scalar will present here, so there is no use of doing operations or whatever, so rank will be the 2. Okay, fine. Now coming to the shortcuts, let's say we're having 3 cross 3 matrix. Just find the rank. So sorry, just find the determinant. When you find the determinant here, so 30 minus 26, it is nothing but 4, and again when you calculate for 2, it is 10 minus 12, and minus 2 minus 2 4, so rank is getting 0. So when you are getting rank as a less than, rank is, sorry, determinant is equal to 0, then that rank will be less than the dimension. Now go for 2 cross 2 matrix in sub matrix. Let's take this sub cross 2 matrix. So 1503, so you are getting rank that as a non-zero, and again you can do here 10 minus 12 non-zero, and again here you will get non-zero, so here rank will be 2. So if any case in submatrix 2 also you are getting determinant as a 0, then rank will be the 1. Okay, we will see one more example for that. Let's say you are having matrix 1 2 3 and 2 4 6 and 3 6 9. By seeing matrix you can say rank will be the 1, but I want to prove this one by the determinant concept. When you calculate the determinant here, you will get 0. Okay, similarly when you take sub 2 cross 2 sub matrix, then again you will get determinant 0. So here if I take this sub matrix, you will get 0. 4 minus 4, again here 12 minus 12, again here 12 minus 12, 36 minus 36. So then what will be the single coefficient? Here you can see if you take any one, then determinant won't get 0, so its rank will be, as well rank will be 1. Okay, so similarly if you see one more example, let's say we're having some matrix A equal to 1 2 3 2 3 1 3 1 2. So now I want to calculate the rank of this matrix. So here you want to make 0, here you want to make 0. How you do that? So R2 implies R2 minus, and R3 implies R3 minus 3 times R1. So what will be the next step? So 1 2 3 will be the same, and here we will get 0, and here 2 times means minus 1, and again here 2 times means 6 means minus 5. Similarly here when you do with 3 0, and here minus 5, and again here 9 is minus 7. So you can see here there is no linear dependency presence from the among the rows or among the columns also. So now you can say rank will be 3. Similarly if you calculate data of this matrix also, it won't get 0, so you can directly say rank will be the 3. And similarly you will see some examples with 4 rows and 4 means 3 columns. Let's say you are having matrix 1 minus 1, and let's say 1 minus 1 minus 1, and 1 minus 1, 2 minus 1, and 3 1 0 1. So now we're having 3 cross 4 matrix. Okay, for calculus remember here rank will be less than uh, minimum of 3 comma 4. Let's say the dimension is 3 cross 4, so rank will be maximum 3, it won't be 4. Okay, so first we will apply some row operations here. So here you want to make 0, here you want to make 0. How we will do that? So R2 implies R2 minus R1, R3 implies R3 minus 3 times R1. Okay, so row 1 will be the same. So row 1 will be 1 point minus 1 minus 1, and row 2 will be 0 minus 2 and 3 and 0. Okay, similarly here 0 minus 2 and here minus 3 and again here 3 means, so what is there, 3 times multiple 1 plus 3 4. Okay, am I correct? I think so, I am correct. So R2 is nothing but R2 minus R1. Okay, so when you do R2 minus R1, 0 and here minus 2 and here 3 and here 0, and again here when you do with 3 0 and minus 2 and minus 3 and already minus 3 is there, here we'll get plus 3 and here at 1 and plus 3 4. Okay, correct. So what is the next step? So you can subtract from R2 implies R2 minus R3. Okay, then I think so there is no use of doing that. Again here 4 will, let's try 1 1 minus 1 minus 1, 0 and 0 and 0 minus 4 and again 0 minus 2 plus 3 and 4. Okay, so again what is the next step here? Now what you can do is these two also, from these two you can say one can be dependent. How? By making these two as a 0. So first we will make this one as a 0. How you can do that? R1 implies R1, R1. Okay, anyway I think so rank will be 3. So we will move to the shortcut. How you can see here. Let's find the rank for this submatrix. So then what you will get 2. Then when you calculate for 1, again you will get when you calculate for minus 1, you will get minus 6. And again when you calculate for minus 1, you will get 3 plus 1, 4, minus 4. So rank will be minus 4 and minus 6 and 10. Rank is not equal to 0. You can say rank is directly. Matrix will be the directly 3. Okay. We will see one more example. Let's say we are having matrix 3 0 2 2 and minus 6 42 24 54 and 21 minus 21 and 0 minus 15. Now what I will do is maximum I will try to apply column operations here. Why? Because here it is multiple of 3 and here it is multiple of 21 and here multiple of 2. Here nothing is there. So what I will do is C1 by 3 and C2 by 21 and C3 by 2. So what I will get? So 1 minus 2 7 and 0 2 minus 1 1 12 0 2 54 minus 15. Now my matrix reduced into single digits. Now I can apply any operations here. So now what I will do is C1 implies C1 plus C2. Then what will happen? So 106 and 0 2 minus 1 1 12 0 and 254 minus 15. Okay, so now again what I will do is C3 implies C3 minus C1. Okay, then what will happen? 106 0 2 minus 1 0 and 12 and minus 6. Okay, so 254 minus 15, again it will be the same. Similarly, when I apply for C3, C3 minus 2 times C1, then so 106 and 0 2 minus 1, it is nothing but multiple of 2, 0 2 minus 1, and here I will get 0 and here 54 will be the same, minus 15 minus 12, which is nothing but minus 27. Okay, now I get Okay, and again, so you can observe here when you divisible by 27, 0 to minus 1. So three rows are similar. So from these three we can keep one. So rank will be 2. Okay, like this you can calculate rank of a matrix. So we will see some more examples also. Uh, let's say we're having matrix. So A will be 1. So 1, 3, minus 1, 2, 0, 11, minus 5, 3, 2, minus 5, 3, 1, 4, 1, 1, 5. So this is your forecast for example. Now I want to calculate rank of this matrix. Okay. So now I need to make here 0 and here 0. So how can I do that? R2 implies, sorry, R3 implies R3 minus 2 times R1 and R4 implies R4 minus 4 times R1. So R1 will be the same 1, 3 minus 1, 2 and 0, 11 minus 5, 3. So now multiplying R1 with 2 and subtracting from R3. So then what I will get? 0 and here 6 is there. So minus 5 minus 6 minus 11 and again here 2 is there minus 2 and here plus 3 is there minus 5 and here 2 is there 4 and 1 minus 4 minus 3. Right. 1 minus 4 minus 3. Be careful about symbols. Here why we are getting minus 11. Okay, minus 5 minus 6 minus 11 5. What is the next step? R4. So 0 you will get here 1 minus 2. What is nothing but minus 11. And again here you are having 1 1 plus 4 5. That is no doubt in that. And again 2 2 sorry 5 minus 8 minus 3. Okay. So be careful about symbols here. I don't know whether I'm correct or not. Now you can cross check. So when you multiply with 3 times 9, sorry, it's 2 times 6, minus 5 minus 6 minus 11. And again when you get there, here you will get plus 2 and 3 plus 2 plus 5 here. Okay. And again here 1 minus 4 minus 3 is 5. Okay. And again here 0, 4 minus 4, 0, and this is 5. Now you can see these three are dependent. So from this you will get 1. So already 1 is there, so rank will be 2. Okay. So there are some properties are there for finding rank or whatever it is. I will discuss those things also. So some properties are there. So rank will always lies between 0 less than or equal to rank of A is less than or equal to their dimension. So minimum, not that exact actual definition, minimum. So when 0 will exist, when you have 0 matrix, then you will get 0. Or else maximum will start with 1. Okay. If determinant is 0 of any matrix, then the rank A will be less than the dimension. If it is not equal to 0, then it will be equal to the dimension. Okay. And similarly, when you are having two matrices, rank of A plus rank of B and minus, and their number is always less than or equal to rank of AB and less than or equal to minimum of rank of A or rank of B. This is some properties where you can remember this property. Okay. So we have done some almost 10 12 examples from your notes. Also you are having so many examples here, you can go through that notes. So let's say wait. Okay, so this will be your rank concept notes. So this is the definition and properties, and you can see here one more extra property is there. Rank of A is always equal to the rank of A transpose also. And we go to the examples. Maximum we have done this type of examples here. Here you can say rank will be 3, and here you can say these two are independent, means dependent on row 1, so rank will be 1. And similarly here this is completely equal to 1, so rank will be 2. And again it is already eliminated and it is dependent on row 1, rank will be 1. By seeing matrix you can say the rank. Okay, and again here you can see 1 2 0 0 1 3 1 3 3. By directly we cannot say rank is 3, but when you apply this row operation, then what you will get? 1 2 0 0 1 3 0 1 3. So it is nothing but 1 will be accelerated, so rank will be 2. So similarly for here 1 2 3 4 5 6 7 8 10. So if you go with row operations, then you will get 4 means 12 minus 6, and here 0 and 7 2s are 14 means 8 minus 14 is nothing but minus 6. And again here 3 means 21 minus 21. Sorry, 10 minus 21 means minus 11. Now you can see there is no dependency presence here. Okay, anyway it is converting into identity matrix. You won't get zeros, complete zeros here. So rank will be 3, or else you can go with that concept also, whatever it is. And again 10210132 G110. I think we have done this example already. So here explanation also given there. This is also done. Okay, and then there will be calculator. You can just give your matrix, it will give the value. Okay, I hope there is no doubt from rank concept. Next we will move to the system of linear equations. If you have any doubts you can comment us. Thank you.